Today we're going to be graphing piecewise functions, which means that we're going to be graphing all different kinds of graphs into one graph. Here's our first example. So let's say we want to graph this piecewise function. The best way to start it is to look at each piece separately. So first I'm going to begin with this part of the function. And I'm going to make a table of values so that I can see what is happening on that part of the graph. This right here, it says the x values that are going to be in this part of function are when they are less than or equal to 1. So this is where I want to start because I know something is happening there. So I'm going to start at 1 and I want the x's that are less than 1. So I'm just going to choose 1, 0, and -1 to kind of give me some values so I can see where the graph is going to go. So I'm going to plug in 1 into that piece of the function. 2 times 1 is 2, minus 1 is 1. I'm going to then plug in 0 into the function. 2 times 0 is 0, minus 1 is -1. Then I'm going to plug in -1. 2 times -1 is -2, minus 1 is -3. So let's graph that part of the function now. So 1, 1 would be right here. Notice at 1, 1, I'm going to put a star here because this was where the function begins. This piece of the function begins, I should say. And notice it is equal to. Remember, when it's equal to, that means a closed circle. If it's not equal to, that means open circle. So it is equal to 1 at this point. So at 1, 1, I'm going to put a closed circle for that piece of the graph. I also have a point at 0, -1. So 0, -1 would be right here. And -1, -3 is here. So I can see if I continued to put more x values that it would keep going down and down and down. So I can know it starts here and my graph is going to continue to go in that direction. Okay, so that represents the first piece of this piecewise graph. Now, let's look at the second piece. Again, I'm going to make a table of values. And this function, it says for x's that are greater than 1. So 1 is a key point again, but I want to put a star by it because it's not going to be equal to 1, which means it's going to be an open circle. So when I get to that point, I want to remember that. Since the x's are greater than 1, I want to choose values that are larger than 1. So I'm going to choose just 1, 2, 3. Always just pick basic numbers to make it easier for you. No reason to overcomplicate this. So I'm going to plug in 1 to this piece of the function. 3 times 1 is 3, plus 1 is 4. Plug in 2. 3 times 2 is 6, plus 1 is 7. Last, I'm going to plug in 3. 3 times 3 is 9, plus 1 is 10. So now I have some values to be able to graph for this piece. 1, 4, remember we said it's not equal to 1, so that's where my open circle is going to begin at. 1, 1, 2, 3, 4, right here is going to be an open circle. 2, 7 is another point on my graph. 2, 1, 2, 3, 4. Up here somewhere, and then 3, 10 is off of my graph, but we know it's up here somewhere. So that tells me the graph starts here and it's going to keep going into that direction. I also see that this is a linear function, which helps me know that this is going to be a straight line for both of these pieces because both of these equations are linear. Also to note, this is called a jump discontinuity because you'll notice that we have a jump in this function, but this whole graph represents this piecewise function. Now, one last question to answer on this problem is I asked the question, what would f of -3 be? That means for this function, what would the value of -3 be? Well, I know that I want to plug in -3 into the first piece because that's where the x's are less than -1. So if I plug in -3 here, 2 times -3 is -6, minus 1 is -7. And so if I was going to graph it, I could go to -3, -7, and it would be down here on the graph, but I can plug in that number. So keep in mind the reason I plugged it into the first part of the function was because it met this requirement. So when you're trying to decide where to plug it in, be sure you look at the requirements first. All right, let's do one last piecewise example. This scenario is like you have a job, and a lot of jobs pay you a base rate, and then if you work more than 40 hours, they typically give you time and a half. So this scenario represents that. In this function, you'll notice you are paid $7 per hour if you work between 0 and 40 hours in this week. Then this piece of the function represents how much you'll make time and a half if you work more than 40 hours in a week. So let's go ahead and graph this function. Notice I've already set up my graph to have hours for the x-axis and how much money is in the paycheck for the y-axis. So again, I'm going to make a table of values because it kind of helps you represent where the graph is going to go. All right, so I'm going to begin if we work 0 hours. 0 hours, 7 times 0 would mean we're going to make $0. That one kind of makes sense. So let's pick some more values between 0 and 40. We know we're going to end on 40, so let's go ahead and choose that and something in between. How about 20? So if I plug in 20 here, 7 times 20 is 140. And if I plug in 40, 7 times 40 is 280. So now I have a beginning, middle, and end for this piece of the function. So let's go ahead and graph it. 0, 0 would be right here. 20 hours, we make $140, which is about right there. And 40 hours, we're going to make 280, which is right here. Now this will be a filled in circle because if you'll notice, it's equal to. So all the way up to working 40 hours, you still receive $7 an hour. It's just beyond the 40 hours do you make time and a half. Okay, now let's look at this piece of the function. This is how much we make if we work more than 40 hours. So for this table, we are still going to begin at 40 hours, even though we know it's just beyond it, because we're going to put that open circle on 40, and then just beyond 40 hours, though, we now start making time and a half. So if I plug in 40 into my function, and it looks like in the function I forgot the h here, because it should be 10.5h minus 140. So I'll type into my calculator, 10.5 times the 40 hours minus 140, that is the 280, which we expected because that was this amount that we were making before. So we don't need to include that even though we know it's beginning there. All right, so let's choose another point. How about if we worked 60 hours? I'm going to plug in 60 here, 10.5 times 60 minus 140, or 90. So if we work 60 hours, we make 490. So that means this piece of the graph is going to be going up like that, and this piece of the graph is going to be going like that. So this graph and these tables could help us figure out how much we are going to make no matter how many hours we work. Let's say you work 80 hours that week, which sounds pretty crazy, but people have done it before. Plug in 80 into this function. 10.5 times 80 minus 140. $700. So you could use this piecewise function to help you figure out how much money you would make at no matter how many hours that you worked. So that's the basics of piecewise function. These take some practice, so practice them on your own and they get easier and easier.